When things change, as in having the inequality symbol reverse, we must be careful to pay attention and notice exactly when the changes must be made. As long as things are remaining the same, we can relax a bit. But when they must change, we really have to be on our toes. Let's summarize the two places where you reverse inequality symbols. Do you remember what they are? One of them is still on the screen. The other one has been up here earlier, but it's been a few minutes since we saw that. So here are our two places for reversing the inequality symbol. Reverse the inequality symbol when you, number one, switch sides, and number two, multiply or divide by a negative number. Reverse the inequality symbol when you, 1, switch sides, 2, multiply or divide by a negative number. These are the only two places where you do reverse the inequality symbol. So remember these two places. Switch sides, multiply or divide by a negative number. Well, now we're ready, at last, to solve inequalities. To solve a linear inequality, let's take this line by line. To solve a linear inequality, proceed as if it is an equation. To solve a linear equality, proceed as if it is an equation. Keep the inequality symbol unchanged unless, and you can finish this out now, can't you? Unless you switch sides or multiply or divide by a negative number. To solve a linear inequality, proceed as if it is an equation. Keep the inequality symbol unchanged unless you switch sides or multiply or divide by a negative number. To solve a linear inequality, proceed as if it is an equation. Keep the inequality symbol unchanged unless you switch sides or multiply or divide by a negative number. Let's look at some examples of linear inequalities. In each case, the instructions are to solve and graph. So we're going to cover both types of things, solve and graph. Our first example is 7x subtract 3 is greater than or equal to 5x subtract 7. We are to proceed as if this is an equation. Notice that the first step in solving an equation is to simplify each side of the equation. But on the left-hand side, we have variable and constant. They cannot be simplified. On the right, we have variable and constant. They cannot be simplified. We can rewrite the subtract as add the opposite, so we'll do that. There are no fractions, and so multiplying by the common denominator is unnecessary. So that gets us down to the third step in solving equations, which is to sort laundry. Sorting laundry is our pet phrase for removing the constant from the left and removing the variable from the right. Let's begin by removing this constant from the left. To do so, we'll add 3 to both sides. And so we write 7x plus negative 3, add 3. On the right, 5x plus negative 7, add 3. Now, what about the inequality symbol? We have added the same thing to both sides of the inequality. That is not one of the two cases that requires us to reverse. Therefore, the inequality symbol remains unchanged. We have greater than or equal to. Now, adding negative 3 and 3, they cancel. That is, they add up to 0, and so their effect is to cancel. That leaves us 7x on the left. On the right, we can add the negative 7 and 3, so that we get 7x on the left, and on the right, 5x plus negative 4. To get from line 2 to line 3 in this inequality, all we've done is simplify. That is not one of the two cases that reverses the inequality symbol, and so we keep it unchanged. Now we must remove the variable term from the right, so we'll add negative 5x. Adding something to both sides of the inequality does not reverse the inequality symbol, and so we have 7x plus negative 5x is greater than or equal to 5x plus negative 4 plus negative 5x. We continue by simplifying. On the left, 7x plus negative 5x is 2x, and on the right, the 5x and negative 5x add up to 0, and so cancel, leaving us with negative 4. We've only simplified, and so the inequality symbol remains as it is. Now the only thing left is to remove the coefficient of the variable. To do that, we divide both sides by 2. And so I'm copying 2x, negative 4, and divide both sides by 2. When we divide by a positive number, the inequality symbol remains unchanged, and so we keep the greater than or equal. 2x over 2 reduces to x, negative 4 over 2 reduces to negative 2, and so we get x and negative 2. The inequality symbol remains unchanged, and so our inequality result is x is greater than or equal to negative 2. Now we're asked to graph the graph of this inequality. X is greater than or equal to negative 2. Boundary number is negative 2, so I'll pick something convenient and call it negative 2. To the right I have negative 1 and 0. To the left I have negative 3, negative 4, negative 5. The boundary number is negative 2, so I'll circle that. We do have the equal. Negative 2 is greater than or equal to negative 2, so we fill in the boundary number point. X greater than typically goes to the right, so let's check on the right first. Negative 1, we fill in negative 1. Negative 1 is greater than or equal to negative 2, so our hunch is correct, and we shade to the right. To the left, we try negative 3 as a double check. Negative 3 greater than or equal to negative 2. No, that is false, so we do not include that portion. For our second example, a fraction. Negative 5/6 times, in parentheses, n plus 1 less than n subtract 1/3. Proceed as if this is an equation. That means we must simplify the left-hand side. Negative 5/6 will be distributed through the parentheses to give us negative 5/6n plus negative 5/6. On the right, n plus negative 1/3. We have simplified on each side. Notice that this negative 5/6 was not multiplied by both sides of the inequality. It was simply distributed through the parentheses, and so the inequality symbol does not reverse, it stays unchanged. Now we have fractions. We can eliminate fractions by multiplying by the common denominator. Our fractions have denominators of 6, 6, understood 1, and 3. Common denominator is 6, so let's multiply both sides by 6. 6 times, in parentheses, negative 5 6n plus negative 5 6. On the right, 6 times, in parentheses, n plus negative 1/3. We have multiplied both sides of this inequality by the same positive number. Multiplying by a positive number keeps the inequality symbol unchanged.